All right, good morning. All right, so today is Wednesday, and we will be doing topic 3, SAS 3, generalizing transformations, and then you have that worksheet that's under files on Teams. And for that, I just want you to write your answers on notebook paper and bring that to class tomorrow, and we're going to go over it and talk about it. All right, so first, it says, in the last exploring, you learned how the values a, h, and k in the function rule y equals a times x minus h squared plus k affect the graph of the quadratic parent function y equals x squared. All right, we know those are quadratic functions because it has that square. Now, the next question says, did these constants affect the graph of any parent function? Yes, they changed the graph. They transformed the graph. The function graphed here is an example of a piecewise function. We haven't talked about piecewise functions, but hopefully you've heard of that in your previous math classes. A piecewise function is one made up of pieces of several different functions. So, on your computer right now, I want you to explore and use these arrows to see what happens. So, if you look from here to here, we have a quadratic function. But from here to here, we have an absolute value function. Okay, so that's where the piecewise comes in. So, the same rules apply as what we talked about yesterday. So, if you look at A, you notice that if A is greater than 1, the graph becomes more narrow than the original. Now, if I go back to 0, I got almost a straight line. Let me get it exactly. There we go. Straight line right on 0. If I go less than 0, you notice that the graph does two things. It flips across the x-axis, and then if that negative is greater than 1, then it becomes more narrow. Now, if we go back to 0 and start again, we start with our straight line. Between 0 and 1, the graph is wider than the original. Same thing for the negative. If it is between 0 and negative 1, it is wider. And remember how we know that. When you are less than 1, you're a baby. You're a fat baby. Okay? If you are older than 1, you're starting to get taller. So you're going to become more narrow. Okay? Silly way, but I promise it helps remember. All right, so now we're going to look at H. If H is positive, we go to the right. If our H value is negative, we go to the left. K. If K on the outside is positive, we're going up. And if K is negative, we are going down. Okay, so I want you to be aware that today we are not dealing with quadratic functions, but we are dealing with piecewise functions. So, on number 1, on page 71 in your workbook, it says, what name is given to the type of function graphed here? A function that appears to be made up of several different functions. It's called a piecewise function, okay? Next thing I want you to notice is this equation right here. I want you to write that under piecewise on number 1. You notice it doesn't have a square. That's because we're not dealing with full quadratics. We're dealing with piecewise, which has different pieces of different functions. So this right here is so important to know. All right, I am going to click to the next page. All right. We're on number 2. It says, how does the value of A affect the graph of the general function rule y equals A times f of x minus h plus k? All right. So before you hit check, I want to write it because I explain it a little bit different and a little bit easier than what they do. It's the same thing as yesterday, guys. The rules don't change. So, if A is greater than 1, meaning it is positive, the graph will be vertically stretched. And that just means it'll become more narrow. If A is between 0 and 1, meaning it is a decimal, it will be vertically shrunk or compressed. Those mean the same thing, and you'll see both. And that simply just means it becomes wider. Now, if A is less than 1, meaning it is negative, okay? It's a reflection over the x-axis. Now, if it is a negative number and it is greater than -1, so it's a -2, then that graph will do two things. It will be reflected over the x-axis, and it would also be vertically stretched. If it is negative, and it is between 0 and -1, so it's a negative decimal, then it will be reflected, and it will be vertically shrunk or compressed, simply meaning it becomes wider, okay? All right, so you can go ahead and click check, and it just kind of says the same thing. Changing the value of A results in either a vertical stretch or a vertical shrink if they're of the original graph of Y. If the value of A is greater than 1, it will be stretched. And then if it is less than 1, it will shrink, okay? And if it's negative, it's just reflected, okay? So I just kind of talk about the same thing, just in a little different way. All right, on H. So I'm going to close this back up so I have a little more room. So for H values, I want you to write this on number 3. What we just wrote should have went on number 2, so this is number 3. How does the value of H affect the graph of the general function rule? Y equals A times f of x minus h plus k. So what I want you to write is plug H into Y equals A times f minus h plus k. So what is very important to know right here is that negative sign, x minus h, that's the function rule, okay? You leave that negative sign. You are only plugging in for the letter H, okay? So if H is positive, it moves to the right. If H is negative, it moves left. All right, so I'm going to do an example. So first, I'm going to say our example is h equals 2. Okay, a positive 2. Now, if I plug h into my equation, I get y equals a times f of x minus h plus k. All right, that's our function rule. Y equals a times f x minus 2 plus k. All right, so here is where your brain might get a little confused. When you see an x minus 2, your brain's probably thinking, oh, I move left. But that is not right because h is positive, okay? Now, if I change this and I say that h is negative 2, here's my function. I'm plugging negative 2 in for the letter h. Y equals a times f x minus a negative 2 plus k. Well, those two negatives make a positive. So I can simplify and say y equals a times f of x plus 2 plus k. This goes left because this is a negative number. Okay? All right, so now you can click check on h, and it says the same thing. If h is positive, the graph of y will shift h units in the positive direction. If h is negative, the graph will shift h units in the negative direction. Okay? Now, k is the easiest one. K is positive. Means it goes up. K is negative. It goes down. K is the easiest one. All right. I'm going to hit check, and it's going to tell me the same thing. If K is positive, the graph will shift K units in the positive Y direction. So it's just moving up that Y-axis. If K is negative, the graph of Y will shift K units in the negative direction. So it will go down. All right. That was for number 4. Now, I'm going to go to the next page, to number 5, and these are some of my favorite things to do. So, on your number 5, it says the values of A, H, and K will transform the graph of the parent function rule f of x, which is the solid line. So, on your number 5, I want you to write original on the solid line. And then it says so that it matches the graph of the new function rule, which is the dashed. So I want you to write transformed by dashed. Now, what you are doing, you have to do this on your computer or on your phone, whatever you're working on. You have to move each arrow to try to match the dotted line. So let's start with A. The dotted line is a little bit wider. So, for something that is wider, it has to be between 0 and 1. So if you look, your thing should already be on 1. So we're going to have to go down. We're going to have to do some messing around with this. So let's just move it down to a little bit. Now, in order to get to the dotted line, we're going to have to move this K down. In order to match it, we're going to have to move it to the left. They still don't match. you notice that they have to keep going down. So we got to keep going down. We're almost there, but our dotted line is a little bit wider. So let's move that down and it matches. So when you get a yellow background on your red line, that is your function rule. So on number 5, here's what we need to be looking at. So what I want you to write is y equals a f of x minus h plus k. Match the colors. A is purple. A is 0.50. H, you'll notice, in blue is a -4. And K, in green, you'll notice, is a -10. So now we are going to plug those values in. Y equals 0.50 times x minus -4 minus 10. But these two negatives make a positive. So y equals 0.50 x plus 4 minus 10. This is our correct answer. Okay? All right, I want you to click to the next one, and it's going to take you to number 6. Number 6 is the exact same thing. So I want you to go ahead and write your function rule. Y equals a f of x minus h plus k. Now, a equals, h equals, and k equals. You know that a is going to be a negative because what is happening? It's being flipped. Okay? So, we know we're going to have to be on the negative side. Now, we got to match it. All right? It kind of looks the same with. So, K, do we have to move up any? Don't really look like it. But H, we're going to have to move it to the right. Now, you notice that the solid line is still a little bit wider. So we're going to have to keep going down to make it more narrow. All right, we're getting closer. So now we're going to have to go down. We are so close. Oh, almost there. Keep going. Let's go down just a hair more. Bam. All right. So, A equals a -3 because it's in the purple right here. H equals +4. We had to move it to the right. And K is a -5 because we had to go down. So, Y equals -3 times F minus 4 minus 5. All right, so all I did was take these 3 values and simply plug them in to this original equation, okay? All right, so now what I want you to do is I want you to do number 7 on your own. And we'll talk about it in class tomorrow. I am going to skip to number 8, and that's a reinforced, so those are really homework ones. So, on number 8, you've got a word bank. All right, you've got A, H, and K. It says the graph of the parent function rule, f of x, the solid blue line, so I want you to write original, has been transformed to create the solid graph of the new function rule, which is the dash. So I want you to write transformed. Fill in the blanks to complete the statements. So it says A, the transform function of the graph is blank than the original graph, so blank. Now, you're looking at, is it more narrow or is it wider? So the dotted line to me looks wider. And then you have to remember, what is that rule? What is that rule? Well, remember, if you were less than 1, you're a baby. And you're a fat baby. So, it is between 0 and 1. Okay? Now, H. That's when it's horizontally. Remember, H, horizontal. H, horizontal. Okay? So, the transform function graph is shifted to the blank, so H is blank. So, from the solid to the dotted, we are having to move to the left. So if we're moving to the left, H must be a negative number. All right, and K just goes up or down. Is that dotted line below the solid or is it above? It would be below. So it is shifted down. And it's down on that y-axis, so it's on the negative side. So it is a negative K. All right. I want you to do number 9 on your own. And let's look at number 10 together. So, what values of A, H, and K will transform the graph of the original, which is the solid again, to match the transformed, which is the dashed? So, first, what I want you to do is I want you to mark the center of each absolute value function. So, here's one. And here's one. So we have a function rule right here. Y equals A F times X minus H plus K. All right. Look at the A. From the original to the dotted, it did 2 things. It flipped, which makes it a negative. And it looks like it got a little bit more narrow. All right, so here's how you can tell. So let me change colors. So I put 2 red dots where it crosses a point exactly. Okay, this is 4 units on my original. Now, I'm going to do the exact same thing down here. That's only 2 units. So what's the difference in 4 and 2? Well, that will be a 2. So our A is a negative 2. Okay? Now H. Remember yesterday I talked about H and K being the center. So, I'm going to erase the red so you can see better. We started at 0, and we have to count over 1, 2, 3. So our H is going to be a -3. And our K goes up 1, 2. So that's a +2. So now that we have these values, we can take them and plug them into our equation. So y equals A. A is a -2 times f of x minus a -3 plus a k, which is our 2. So we can simplify this because this becomes a positive. Y equals -2 f of x plus 3 plus 2. So this is our answer. All right, I want you to do 10B by yourself. So by yourself, you are doing number 7, number 9, and 10B. And we will talk about all 3 of those in class tomorrow. All right, now on the, I'm going to go to the worksheet that's on Teams. And there's a couple of things that I want you to write on the back or on your notebook paper somewhere. So we're just going to write our rules again because you can never write them too many times because you always got to know. So if you look on the right side, you notice that everything has a square. So we're probably dealing with quadratic equations. Look, it tells us. Okay? So for A values, A is greater than 1. Vertically stretched. Narrow. A is between 0 and 1. Vertically compressed or shrunk, just means wider, same thing. And if A is less than 1, meaning it's a negative, it is reflected over the x-axis. Okay? H, horizontal shifts. H is greater than 1, meaning it's positive. Moves right. H is less than 1, meaning it's negative. It moves left. Okay? Here's an example. If it says it is moving to the right 3, well, H has to be a +3. My function is x minus h squared. X minus 3 squared. Now, if it says it moves to the left 3, then h has to become a -3. So, now, minus a -3 squared. These two negatives become a positive, so we have x plus 3 squared. Okay? Last but not least is k. We all know what k means. If k is greater than 1, it is positive, so it is going up. If k is less than 1, meaning it's negative, it is going down. Now, there's a couple ones I want you to fill in. So, for number 2, I want you to write N. For number 5, I want you to write K. For 8, I want you to write D. And 15, I want you to write P. So, you can mark N, K, D, and P off your list. All right, work on these. If you need help, let me know. Bring to class tomorrow. We're going to go over everything. I'm going to do a slight change in our agenda, but it's going to be totally fine. See you all tomorrow.